Hello students, welcome back to your favorite and India's most affordable learning platform, Physics Wallah. So in the last session of laws of motion, we covered the concepts of spring force, right? So how when the string is cut, how do we calculate the acceleration of each block, right? So we have solved n number of questions based on that. And in today's session of laws of motion, that is lecture number 5, so we are going to discuss what is inertial and non-inertial frame, and what is a pseudo force, and where do we apply this pseudo force. Okay, so as usual, for the next 1 hour, just be with me, avoid all the disturbances around you guys, and at the end of the lecture, it's very important to write the short notes. So most of the students feel difficulty in solving the questions of pseudo force, like they confuse where to apply the pseudo force. So all your doubts related to the pseudo force and inertial and non-inertial frame will be clear today. Just concentrate on the lecture. Okay, chal. So let's start with the basics first. What is inertial and what is non-inertial frame? See, the simple thing is, so consider this is a vehicle, and then so here the person is here, the observer. Consider he is the observer. Let's suppose the Chintu is standing here. Okay, so here this vehicle, consider this is a vehicle, it is moving with some acceleration a. So now with respect to the observer, vehicle is moving, but the observer's acceleration still equals to 0. The observer has no acceleration. So such frames are called the inertial frame. This is called the inertial frame. Okay, so if the observer is inside the frame, so such frame is called the non-inertial frame. So consider this is a vehicle, and then so here this vehicle is moving with some acceleration a. Okay, and the observer now is standing inside the vehicle. So now observer is inside the trolley or vehicle, whatever it is. Okay, so then the observer's acceleration here, it's not equals to 0. So the observer's acceleration is not equals to 0. So this is a non-inertial frame. This is the non-inertial frame of reference, we call non-inertial frame. So for the non-inertial frame, so the Newton's laws are not valid. For inertial frame only the Newton laws are valid here. So for inertial frames, the Newton laws are valid. Right? So whereas for non-inertial frames, so the Newton's laws are not valid. Newton laws are not valid. So then to make it happen, to make Newton laws valid for the non-inertial frame, so what is the procedures are? So here comes a concept of the pseudo force. So here we talk about the force which is called the pseudo force, which is nothing but, the pseudo means fake. The pseudo is a fake force. Like where do we apply this fake force? So whenever the observer is inside the accelerated frame, remember carefully, the only difference between inertial and non-inertial is, if the observer's acceleration is 0 with respect to the frame, so then that's said to be the inertial frame. If the observer is inside the frame, okay, so then such frames are called the non-inertial frame, where the observer will have the acceleration same as of the trolley, right? So then, so in such cases the Newton laws are not valid. So to make the Newton laws valid, so what we do is, so we apply the pseudo force. Okay, so this is a concept. So where do we apply the pseudo force? This pseudo force will be applied, so opposite to the, this pseudo force is applied opposite to the acceleration. Opposite to the acceleration. Just understand, I'll give you the examples, n number of examples I'll give you. Okay, chalo. So now let me take the examples. See here, consider, let's suppose here is a vehicle or trolley. First example I am giving, this is the example 1. So and then the person is here, and then this is a trolley. So the trolley is moving with some acceleration a. The trolley is moving with some acceleration a. So now the pseudo force will be applied. So let the person's mass be m. Pseudo force I am talking about. So the acceleration is this side. So opposite to the acceleration, the pseudo force will act. So the pseudo force, that is mass of the person into that acceleration, that ma will act out opposite direction. So that ma, the pseudo force is a ma which acts opposite to the acceleration in this particular case. So or let me take the example 2. Consider the example 2. So let's suppose this is a lift. So now inside the lift there is a person. Okay, so this person has some mass m. Now let's suppose the lift is accelerating upward. So now see here, the observer is in the accelerated frame. The observer is in the accelerated frame. So in such case, what happens? So the weight, the acceleration, and then the pseudo force ma will act opposite direction. We can write, so his weight will be there, and as well as the pseudo force, which is his mass into acceleration. So this is the pseudo force which acts opposite to the acceleration, right? And similarly, let me take one more example, guys. Here, consider example 3. So let's suppose this is the inclined plane. Consider this is a inclined plane, and this inclined plane has mass capital M, let's suppose, and then so this on the inclined plane we placed a small mass m. Now this whole plane is moving with an acceleration a. This whole plane is moving with an acceleration a. So now shall I say that, consider the person is standing here. The person is standing here. So now the observer is in accelerated frame. I can say the observer is in accelerated frame, right? So that the pseudo force comes here. So obviously the pseudo force that acts here, it is ma. A acceleration right side, so therefore ma left side. Clear? So if you take this angle as theta, so this ma will have two components. Yes or no? So this ma will have two components. So we generally take for the inclined plane, so this as a x-axis and this as a y-axis, right? We change the frame of reference. This is the x-axis and then this will be the y-axis. So here ma will have two components. What are the two components of ma? This is one component and then this is another component. Yes or no? So this is one, see ma is this side. So we change the frame of reference to this is x-axis, this is y-axis, right? ma is this side, that's why ma will have component this side and component this side. Done this part. And see, if this angle is 90, so this is theta, so this is going to be 90 minus theta. This is going to be 90 minus theta. So obviously this side the ma sin theta component will come, and then this side ma cos theta component will come. Why, sir? So if this angle is theta, so I can say here also the angle will become theta. Yes or no? So here the corresponding angle, if you draw the horizontal here, this is the theta, so then this angle is going to be the theta, so the corresponding angle, and then this is again the 90 minus theta, I can write. Yes or no? So that's why if theta is this side, this is theta, my bad. This will become theta, sorry, this is, if this is theta, this becomes theta, the corresponding angles, right? So if it is theta, this is going to be ma cos theta, the cos component, and the sin component will come this side, ma sin theta. Clear? So just the components we are writing. Okay, this is a just basic understanding of what is inertial and what is non-inertial frame, and in which cases the pseudo force will be applied and how to apply that pseudo force. Is this concept clear, guys? Now, so I have taken so n number of some examples here. So let me take the example 4 also. Consider, let's suppose same lift. If the lift is moving accelerating downward now, so the person is inside the lift. Let's consider the observer is inside the lift. So then here its mass is m, the person mass. So obviously the pseudo force will act opposite to the acceleration. So which is ma this side, ma upside. Clear? Done? Chal. So let's move further. So let's understand the concept by questions. By solving the questions, I am going to take at least 10 questions in this session. So related to the pseudo force. So all your doubts related to pseudo force will be clear today. Okay, chalo. So pause the video, try it on your own, guys. First, see what's the question says here. A bob of mass m is suspended from the ceiling of a train moving with an acceleration a as shown in the figure. So find the angle theta. So in equilibrium position, find the angle theta in equilibrium position. So first understand the concept here. So this is a trolley which is moving with an acceleration a. The trolley is moving with an acceleration a. So then here the bob of mass m is attached. Obviously when the acceleration is right side, so this one will be tilted to the left. Yes or no? This bob and the rope string, so they will be tilted to the left by an angle theta. This is clear. So now let me take this part. So actually it has to be like this, but with respect to the vertical, so it tilted by an angle theta. So now let's draw the free body diagram and what are all the forces acting on it first. So shall I say that its weight mg acts downward, its weight mg acts downward. So now what I am considering is, consider, let's suppose the person is standing outside and he is observing this train. Imagine I am going to solve it in two cases. In both the cases we should get the same result. So the person is outside now. So that means the person is in inertial frame. Yes or no? The person is in inertial frame. So now the weight of the bob is mg this side, and here the tension acts. Yes or no? So then if I take this as a horizontal, so if this angle is theta, so or else let's take not horizontal, consider the vertical line. So here consider the vertical line. So if this angle is theta, this angle is going to be theta. So obviously this side it's going to be t sin theta and comes. So this side t cos theta. I can write now. So the t cos theta is balanced by mg. The t cos theta is balanced by mg. And then so this bob of mass m, it is accelerating towards the right as per the observer on the ground. So this is accelerate, the whole acceleration is right side. So that's why the net force, what is our net force acting t sin theta, which must be equals to ma. I am applying the Newton's second law here. Its acceleration is towards right, the train acceleration. The person is observing from here. So what is the force that is acting right side? T sin theta, the net force, and its mass into acceleration. So let it be equation number 1, let it be equation number 2. So now let's divide 2 by 1. So I can write t sin theta by t cos theta is equals to ma by mg. So from here t cancel, sin theta by cos theta, which is tan theta, which is equals to a by g. So from here the theta is equals to tan inverse of a by g, or the acceleration a is equals to g tan theta, or the acceleration a is equals to g tan theta. Clear guys this concept? Just I consider the person is outside and then we apply the Newton laws, because this is a non-inertial frame where the this is the inertial frame, so where the Newton laws are valid. Clear? Understood? Chal. Just a minute guys, I'll have some water. Yeah, sorry, thank you. Chal. So see here, this part is done. Next, so let's move further. So the same question, let's do it by the another method. So we have got the answer, what they asked, the theta in equilibrium, so which is going to be tan inverse of A by G. So tan inverse of A by G. So the same question, let me do it by considering the observer inside the frame. So let me consider the observer is inside the frame now. So inside the accelerated frame. So shall I say this is now the non-inertial frame of reference. This is the non-inertial frame in this case. Yes or no? So now see here. So for the non-inertial frame, so again let's draw the free body diagram. This is the ceiling, and then with respect to vertical, so it's making some angle theta. So again the same concept, I can say that, so if this angle is theta, this is going to be theta. So this side the t sin theta will come, and the upside t cos theta will come this side. And then one more thing, see here, so its weight mg acts downward. Now you can't apply the Newton's laws here. So what we should do, so as acceleration is right side and observer is inside the accelerated frame, so shall I say that the pseudo force acts left side, so that the pseudo force will be acting left side. So they asked at equilibrium, so they said at equilibrium position. So at equilibrium, I can say that at equilibrium position, so observe this one, at equilibrium, so the t sin theta is equals to ma, t sin theta is equals to ma, and t cos theta is equals to mg. Yes or no? So from here, let it be equation number 1, let it be equation number 2. So then divide these two. So sin theta by cos theta, which is tan theta, is equals to A by G. So from there the theta is equals to tan inverse of A by G. Okay, clear this part everyone? The simple one, or you can also write the acceleration is equals to G tan theta. So this is the standard result everyone should remember. So whenever the accelerator, like if something is attached to the ceiling of mass, which is of mass m, and then so if the acceleration is towards the right, so then what happens, the bob of mass m, it will be tilted towards the left. So it will be tilted towards the left at an angle theta is equals to tan inverse of A by G, the standard result. So if the accelerated frame is this side, let's suppose if the acceleration is this side, so then it will be tilted to the right. Okay, so the direct questions were asked based on this concept. So if the acceleration is to the left, so then it will be tilted to the right. Clear? So towards left, theta, I can say in this particular case it's towards left. Right? Done? Understood the concept everyone? Chalo. So let's move further. So take the question. What's the question says here? A bob of mass 50 grams is suspended from the ceiling of a trolley by a light inextensible string. So if the trolley accelerates horizontally, the string makes an angle theta 37. So with the vertical. So find the acceleration. So simply you can use the tan theta is equals to A by G. So they are asking us to find what is the acceleration, direct formula. So the tan 37 degrees is equals to, so what is acceleration A, we have to find. So let the G, and then this is going to be tan 37, which is 3 by 4, opposite by adjacent. So then A, we have to find G. So from here the acceleration A is equals to 3 by 4 times the 10. So which is nothing but 4 ones are 4, 2.25. So then this is going to be 4, 2.5 I guess. So 4, 2.5 times, and then this is 7.5 approximately. So the 7.5 meter per second square. Simple question, direct formula based one. Done? Clear guys? Chalo. So let's move further. So the next question, the third one. So what's the question says here? If the pulley is massless and moves with an upward acceleration a0, so and find the acceleration of m1 and m2 with respect to the elevator. See here, this whole thing is in the elevator. So here elevator is not drawn. So let's draw the elevator. So this whole thing is in the elevator, and the elevator is moving upwards. Now, perfect. Yes. So see here. So the elevator is moving with an acceleration a naught upwards. So see here, the first thing is, this is a simple pulley, right? Simple atwood mission. So we know that here M2G, let it acts downward, and here M1G that acts downward, right? So now what I am considering is, consider M2 is greater than M1. Consider the M2 is greater than M1. Okay, so in this particular case, so if there is no acceleration to this whole system, whole pulley, we know the acceleration, the basic case, which is equals to simply M2G minus M1G by M1 plus M2, the net mass. Yes or no? M2G minus M1G by M1 plus M2. This is a simple case, simple atwood mission. But here, as the whole thing is accelerating upward, so one force that comes into the role, so here the M2 A naught, its mass into the A naught, the pseudo force on the M2, and the other force that acts is the pseudo force on the M1, which is M1 A naught. Yes or no? So M2 A naught is a pseudo force acting on this, M1 A naught is a pseudo force which is acting on this. If there is no acceleration upward, simply M2G minus M1G by M1 plus M2, that's the acceleration, right? So but here there the whole thing is kept in the elevator is accelerating upward, so therefore the pseudo force will act on each mass, so that is opposite to the acceleration. So on this M2 into A naught, on this M1 into A naught downward. So now the net acceleration, how do we find the net acceleration? So the net force by the net mass, the net force by net mass. Yes or no? So here the net force is nothing but, so this M2 we considered more, so that's why this whole thing minus this whole thing, right? What is that? M2G plus M2A naught minus M1G minus plus M1A naught. This concept is clear. This whole thing minus this whole thing, like this whole thing means we have to add these two, M2G plus M2A naught minus M1G plus M1A naught by, so the whole mass which is M1 plus M2. So from here I can write A is equals to, let's write M2G minus M1G, let's write these two terms at one place, and then plus here M2A naught minus M1A naught by M1 plus M2, right? So from here the acceleration A will be equals to, so M2 minus M1 into G plus M2 minus M1 into A naught, M2 minus M1 into A naught by M1 plus M2, by M1 plus M2. So this is a whole acceleration. Clear the concept? Simple thing. Previously it's simply M2G minus M1G by M1 plus M2, but the pseudo force is coming, right? So what's the pseudo force on this M2A naught, on this M1A naught? So M2A naught minus M1A naught, that is coming extra. This whole thing we already know, so the pseudo force is coming extra, that's it. Done the concept. Sure. Next. So the same question, so no need of extra slide. Let's so the next one, so the apparent weight of the person inside the lift. So as we discussed earlier, consider, let's suppose, so here is a lift, so and a person is standing here inside the lift. Let's suppose, so the lift is moving upward with an acceleration A. So in this particular situation we know that, so the normal force acts upside, the normal force acts upside, and the person mass, let's suppose M, so the person is of mass M, so that his weight acts mg. So if the lift is stationary, the normal will be balanced by mg, right? N is equals to mg. But as the lift is moving upward, so on the person, so there is pseudo force that is acting downward, lift is accelerating upward, so that's why the pseudo force acting downward, mass into the acceleration in the opposite direction. So now the N is equals to, which is mg plus ma. The normal is balanced by mg plus ma. So from here I can say that normal is equals to, if you take n common, so it will be m common, so n is equals to, so mg plus ma, m of g plus a, right? So this is a weight. So that means, so actually our weight should be equals to mg. Normal is nothing but our weight, right? So the normal will be balanced by our weight. So but here one more extra component that is coming is ma. So that's why whenever you are traveling, whenever you are moving upwards in a lift or elevator, so we feel like our weight is, we feel our weight is more than our actual weight. Okay, we feel our weight is more than our actual weight. That's the reason. Clear? And similarly, consider if you are descending in a lift, so with an acceleration a, so consider here is a person and then whose mass is m. So the normal reaction, because he stands inside the lift, so there is a contact force, so the normal is upward, and then so his weight mg downward, and as the acceleration is downward, I can say that the pseudo force which acts on the person, that is ma, mass into acceleration and in the opposite direction. So now in this particular case, so I can say that the normal and ma both are in the same direction. N plus ma is balanced by mg, So from here the normal is equals to mg minus ma. The normal is equals to mg minus ma. So from here normal is equals to m of g minus a. So actually our weight should be equals to mg. So but from our weight some component is getting subtracted. See here, mg minus ma, some component is getting subtracted. So which means that whenever we are going down or descending in a lift, so we feel like our weight is less than our actual weight. So have you ever felt this? So whenever we are moving in a lift upwards, so we feel like our weight is greater than our actual weight. So when we are descending or accelerating downward, so then our weight, we feel like our weight is less than our actual weight. We feel like that, right? So the reason is the pseudo force. Clear? Understood, guys? Everyone? Sure. So note this point. This is also one of the important concepts for your competitive examinations. So the questions will be picked directly from here. Okay? Sure. So next, see here. So what's the question says? A man weighs 80 kg. So he stands on a weighing scale in a lift which is moving upwards. So with a uniform acceleration 5 meter per second square. So what would be the reading on the scale? See here. So here is a elevator. So then, so the person of 80 kg. Here the person weight is 80 kg. So the moving upwards with an acceleration 5 meter per second square. So what would be reading on? So they are asking his weight. Simple question. We know that the normal reaction acts upside, and then his weight mg downward, and then the pseudo force ma downward. So we know that n is equals to simply mg plus ma when the lift is moving upward. So therefore n is equals to m of g plus a, right? So here the g, they said clearly take it as 10. So what is mass? 80 into, so a 10, g 10, a 5. So which is going to be 80 into 15. So this is 120, which is nothing but the 1200 newtons. Option C is the correct one. Done. Direct formula based question. Clear? Chal. So next, so the question number 5. Understand the question, guys. A truck is stationary and has a bob suspended by light string in frame attached to the truck. So consider this is a truck. So inside the truck, so there is a ceiling string, and then this is a bob of mass m which is attached, right? So then fine. So the truck suddenly moves to the right. So the truck suddenly moves means it accelerates to the right with an acceleration a. So the pendulum will tilt. So the first thing is the pendulum will tilt towards the left. So the pendulum will tilt towards the left at an angle theta. So to the left, to the left, to the left, to the left. So all options are possible in the question, right? So and angle of inclination of the pendulum with the vertical is tan inverse of g by a. No. So and the angle of inclination of the pendulum with the vertical is sin inverse of g by a. No. So then the angle of inclination of the, this is tan inverse of a by g. This is correct. Tan theta is equals to a by g, right? We have seen this condition where, so this one. So tan theta is equals to a by g, or theta is equals to tan inverse of a by g. So direct question, this one. So tan inverse of a by g. So again sin inverse, you can cancel this. Clear? Understood, guys? Sure. So let's move further. So let's take one more question. What's the question says here? All surfaces are smooth in the figure. So find f such that the block remains stationary with respect to the wedge. See here. This is a wedge which is of mass capital M. And then, so this is the angle theta here. And then on this wedge, so the small m is placed. The block of small m is placed. So now this whole wedge, on the whole wedge, the force applied is F. The force applied is F. So now what they are saying that how much should be this force in such a way that this block should be in rest. This small m block, like if you apply the force, what happens? It accelerates to the right. Yes or no? If you apply the force in this direction, obviously the acceleration is towards the right, the first thing, right? So what should be this force now, so that this block should not slide. Though this total wedge is moving, accelerating right side, this block should not slide on the wedge. That's the question. It should be rest, stationary with respect to the wedge. See here, they said with respect to the wedge. They said with respect to the wedge. So with respect to the wedge means I am considering a person on the wedge. Let's consider an observer who is sitting on the wedge. Let's say like that. So now the acceleration is right side. The acceleration is right side. So I can say that the first thing, the weight mg acts downward. What are all the forces? This should be stationary. This should be stationary, yes or no? So first write all the forces acting on it and apply the equilibrium condition. That's it. So the force acting on it is, and the weight is mg. And then, so as the acceleration is right side, I know that the pseudo force will act left side. The pseudo force ma will act left side because the acceleration is right side. Now what we do in such questions, in the inclined plane questions, we change our frame of reference. This is your x-axis, this becomes your x-axis, and then this becomes your y-axis. Yes or no? According to our frame, we change the frame of reference like this. So the x-axis and y-axis. Yes, see here. So the mg components we already know. If this is theta, so this is 90, and this is going to be 90 minus theta, and obviously this is going to be theta. So that this side we get mg cos theta component. Observe carefully, guys. Mg cos theta, and along the inclined plane mg has two components. One is this side, one is this side, right? This is mg sin theta. Along the inclined plane we get the weight sin component, mg sin component, and along the perpendicular we get mg cos theta. So this part is clear. Done. Now the thing is, here ma will also have components because it is neither in the y direction nor in the x direction. It is also with some angle. Yes or no? So this ma will have two components. What are the two components of ma here? So let me take this color. So the ma will have two components here. ma will have two components. So this is one component of ma, and this is one more component of ma, I can say. Understanding? So what are those components? So just draw the figure again. See here. If this angle is theta, this angle is going to be theta. So this should be 90 minus theta because this whole thing is 90, right? X-axis, y-axis, this whole thing should be 90. That's why if this is theta, this is also theta. Done. Yes, chal. So I can write now that this side theta is there, so that's why MA cos theta component will come this side, and then MA sin theta component will come this side. MA cos theta component will come this side, MA sin theta component will come this side. So now the small m block is stationary. The small m block is stationary. Stationary means, can we apply the equilibrium condition? It is stationary, which means we can apply the equilibrium conditions on that particular block, right? So let's apply the equilibrium conditions. See, so I can say that the MA cos theta is balanced by MA cos theta is balanced by mg sin theta, mg sin theta. So then I can write here that, so that MA cos theta, so I can write MA cancel, so MM cancel, sorry, I can write here sin theta by cos theta. So tan theta is equals to A by G, or we can simply say acceleration is equals to G tan theta. This we already know, right? This we already know. For the inclined plane also, if it is moving with some acceleration A, so what is that acceleration? G tan theta it's going to be. So now the second thing is, sorry, so let me add the slide here. So the second thing is, so the vertically we have mg cos theta, ma sin theta, which must be balanced by the normal here. Wherever there is a contact, so there comes a normal reaction. So the normal will be like this. So now the normal is balanced by, I can say that now the normal is balanced by mg cos theta, right? And then ma sin theta, ma sin theta. So mg cos theta, yes or no? Yes. So the normal is balanced by mg cos theta plus ma sin theta. So what we have to find actually? So we have to find what is the force F. So what is the force F? Okay, fine. So this must be, the force is equals to, let's apply the Newton's second law. So we don't need normal, I guess. Let's suppose this is N, which M, take it a common. So this is G cos theta plus A sin theta, right? So what is the force formula? Let's apply the force formula on this. So the force is equals to mass into the acceleration. The net force is equals to net mass into, this is just normal, let it be aside, don't get confused guys. So I just wrote the equilibrium conditions, so that we got acceleration is equals to G tan theta and the normal is equals to mg cos theta plus ma sin theta. But in the question they are not asking about the normal, forget about that. So we just need the force. So on this block the force is acting right side, right? Now apply the Newton's second law. So what is the Newton's second law? So we know that F net is equals to m net into the acceleration. What is the net mass? The net mass is capital M plus small m, the wedge plus the small m block. So the net mass is m plus m, right? So what is the acceleration we got? Simply G tan theta. So this must be the net force acting on the body. The force F is equals to m plus m into G tan theta. So m plus m into G tan theta. That's it. Actually this part is not required, just for your understanding I wrote normal reaction. They did not ask about the normal here. So we just need the force F, horizontal one only. Done? Clear guys? Chalo. So let's move further. Let's take one more question. So which was asked in NEET 2018. So what's the question says? A block of mass m is placed on a smooth inclined wedge ABC of an inclination theta. So shown in the figure, the wedge is given an acceleration a towards the right. So the relation between a and theta for the block to remain stationary. See here, the block to remain stationary on the wedge. So this block should remain stationary with respect to the wedge. So what we consider, the observer is here, let's suppose. So then what are all the forces? See here, we know that. Let's change the frame of reference guys. So how do we change the frame of reference? This is your x-axis and then this will be your y-axis now. This will be your y-axis, right? Fine. So now change the we change the frame of reference. What are the forces now that are acting? It's weight mg which is acting downward, and then the pseudo force ma which is acting left side, right? So now the two components for the mg, so one is mg sin theta this side, and then this side mg cos theta. Alright, we have already seen. So same in the similar way, so we can write for this also. Previously we wrote, if this angle is theta, this is going to be theta. So that's why this is going to be ma cos theta, this component of ma, and one more component of ma will come this side, which is ma sin theta. So what they are asking? They are asking what is the relation between a and theta. So the first thing is, so the horizontal equilibrium. Consider the horizontal equilibrium. Consider the horizontal equilibrium. So in the according to the horizontal equilibrium, this is the x-axis, which is horizontal equilibrium. So I can write ma cos theta is balanced by mg sin theta. The same thing we are doing again and again here. So cancel. We know that the tan theta is equals to a by g, and the acceleration a is equals to g tan theta. The acceleration a is equals to g tan theta. Let it be aside. And then next, so let's take the vertical force. So the normal is balanced by mg cos theta plus ma sin theta. Mg cos theta plus ma sin theta. Mg cos theta, yes or no? Mg cos theta plus ma sin theta. So now let's write n is equals to, I am writing mg cos theta. Let's write, so in place of a, let's write g tan theta. In place of a, let's write g tan theta into sin theta. So from here the n is equals to, let's take mg common, so that here cos theta will come out. So in place of tan theta, I am writing sin theta by cos theta. Just basic maths. I am not doing anything more here. Just understand carefully here. So we are just doing mg cos theta plus ma sin theta is a normal, right? So from here in place of a, I am writing g tan theta. So that here mg common. So here cos theta is left. Here in place of tan theta, I am writing sin theta by cos theta and sin theta. So then n is equals to mg of, here cos theta is the LCM. So here it goes cos theta times cos theta into cos theta, the cos square theta, plus here sin theta into sin theta, sin square theta. Right. So from here n is equals to, so from here I can write n is equals to mg into, so here sin square theta plus cos square theta, 1 by cos theta. So I can write here n is equals to mg by cos theta. So that's it. So that's what they asked in the question. So what is the relation between the acceleration a and theta? So the acceleration a, mg by cos theta, so which is mg by the acceleration a required, right? So in place of n, we can write a, which is nothing but ma, so which is nothing but mg by cos theta. So from here n cancel, right? So the acceleration a is equals to g by cos theta. Yes or no? So the acceleration is equals to g by cos theta. It is, I guess, by. It should be g by cos theta. Option g cos theta, no. What they said? The normal we got. Correct only, right? So any mistake we did? N is equals to mg cos theta, mg by 1 by cos theta, fine. So n is equals to mg by cos theta. So we got normal. A is equals to, in place of g, is correct only. So this must be g by cos theta, correct only, guys. So option C is the correct one. So see here, so in this question directly they asked the relation between a and theta, right? So we did whole thing, not required actually. So simply directly a and theta, a is equals to g tan theta, right? We got here itself. So the normal reaction is not required. Just for your understanding, let it be. Okay, chalo guys. So just a is equals to g tan theta here. Okay, let it be. Let's go for the next question here. So a mass m is placed on a very smooth wedge resting on a smooth surface without friction. Once the mass is released, the acceleration to be given to the wedge so that m remains at rest where? So the acceleration should be a is equals to g tan theta, right? So the acceleration to be applied to the left, right? Here, the acceleration to be applied to the right, A is equals to g tan theta. So the only option A is equals to g tan theta is there in the option B, right? Acceleration is applied to the right, yes or no? So for this, the acceleration is applied to the right so that it will be tilted to the left, yes or no? So the simple question again, the basic one, but they are asking this one, inclined plane, direct formula based questions, guys, nothing more than that. So here the acceleration is applied to the right. How much? A is equals to g tan theta. Already previously we solved the questions, right? Next, see the next question. A block of mass m is placed on a smooth wedge of inclination theta. The whole system is accelerated horizontally so that the block does not slip on the wedge. So the force exerted by wedge on the block, the force exerted by wedge on the block means normal reaction they are asking. See here. So we did the question advanced here. See here. So this is a normal reaction. That's what they are asking. What is the force exerted by the wedge on the block? The wedge exerting the force on the block is normal. They are simply asking the normal force. So the normal is equals to simply mg by cos theta. Just now we derived previously. So let me put that slide here. So this one is, I can write here. You can put it here for this question simply. Done? Shall. So next, so the next question, the 10th one. So in the adjoining figure, see, did you keep the answer? Mg by cos theta, option D. The normal reaction they asked here. So then in the adjoining figure, a wedge is fixed. A wedge is fixed to an elevator. See here, this is the elevator. The wedge is fixed here. So upwards with an acceleration A. So a block of mass m is placed over the wedge. Find the acceleration of the block A with respect to the wedge. So neglect friction. See here, we know that its weight mg act downward and then its pseudo force acts ma this side. Obviously, so this side mg sin theta will come plus ma sin theta will come. Mg sin theta plus ma sin theta. So what they are asking? The acceleration, with what acceleration it accelerates? So the acceleration A is equals to, I can simply write g plus a sin theta. The simple one, guys. So the acceleration A is equals to g plus a sin theta. That's it. G plus a sin theta. Yes or no? Mass gets cancelled, right? Here the net force is equals to mass into the acceleration. So here mass you can take common. So that mass cancel. G sin theta plus a sin theta, which is nothing but g plus a sin theta. Clear? The simple question this also, which is C. So no need of extra slide for this. See here the simple logic that you can remember. So let me add one slide. So I'll write the summary to avoid the confusion. Just 2 minutes, guys. See here. Whenever you placed a bob of mass m, then if the acceleration is given to the trolley to the right, so then this will be tilted towards the left with an angle theta. So where the theta is equals to the tan inverse of a by g. This is a standard result, or with what acceleration it should move? A is equals to g tan theta. If the acceleration is given to the left, so then it will be tilted to the right by an angle theta is equals to tan inverse of a by g. So this is the first point, the standard result. And then, so if this is the inclined plane, and then this is of the wedge of capital M mass, and then this is of small m mass. If you give the acceleration a to the right, so what should be that acceleration? So that this small m mass will be in rest or stationary with respect to the capital M. So which is a is equals to g tan theta. And what should be the force exerted by capital M mass, force exerted by capital M on the small m, which is nothing but the normal reaction, which is mg by cos theta, which is mg by cos theta. Clear? This is clear. This part also. And then, so if you place the object on the inclined plane, so then, so its acceleration is going to be simply g sin theta. If this angle is theta, so this acceleration is going to be g sin theta. So if you place this on inside the elevator, let's suppose if you place this inside the elevator, so if this whole elevator is moving upward, so then what happens? So here is the mass m, so that the acceleration of this will be g plus a sine theta. Just now last question we have seen, right? So and opposite exactly, that is if this is the inclined plane and here there is a mass m placed, so this whole thing is placed inside the elevator, so the elevator is moving downside, so obviously, so here the acceleration will be g minus a sine theta. It will be just opposite of this, g minus a sine theta, because here the pseudo force will act upside, so that's why the ma sine theta component will come this side. So mg sine theta minus ma sine theta, which is nothing but g minus a sine theta is the acceleration. Clear? So these are the standard results and concepts that we discussed in today's session. So that's it, guys. So thank you. So we'll meet in the next session, so that is tomorrow. So till then, keep studying. All the very best. Bye. Take care.